dark energy that roughly constitutes 68% of the universe, and only 5% of the universe are known matters. So we need sufficient data to analyze the properties of this dark energy, which requires proper instrumentation consistent with the theory for future research.
So if we can utilize these dark energy sources instead of the orthodox energy sources which we have been using, then humans will have a carefree life on the earth for at least another billion years to come.
So today we find ourselves in a new age of exploration, which is not really that dissimilar to early ages of exploration that we've been witness to. History tells us that that didn't go too well. And let us hope that this time, the drive to enter space is inspired more by engagement rather than acquisition, and we go there with less hubris and more humility.
The universe is full of matter and gravity pulls all matter together. The Hubble Space Telescope's phenomenal observations of very distant supernovae showed that a long time ago, the universe was actually expanding more slowly than it is today. The universe, therefore, is in accelerated expansion. But what is causing this? Theorists have determined this to be dark energy, of which more is still unknown than known. It turns out that roughly 68% of the universe is dark energy. Dark matter makes up about 27%. The rest, everything on Earth, everything ever observed with all of our instruments, adds up to less than 5% of the universe. Einstein was the first person to realize that empty space has incredible properties, many of which are just beginning to be understood. What human beings are struggling and indeed racing to understand are the mind-boggling possibilities of dark energy. And for that, what is needed is more data and yet more data that can be accorded by instruments and theories together. This session delves into the realm of possibilities in space research that both ideas and instruments together can enable. Be inspired. How the confluence of ideas and instruments has propelled progress in science. Michael Lemonick in conversation with Priyamvada Natarajan. Michael Lemonick, who teaches communications and journalism at Princeton University, is an opinion editor at Scientific American, a former senior staff writer at Climate Central, and a former senior science writer at Time. He has also written for Discover, Yale Environment 360, Scientific American, and others, and has written a number of popular level books on science and astrophysics, including The Georgian Star, How William and Caroline Herschel Revolutionized Our Understanding of the Cosmos, Echo of the Big Bang, Other Worlds, The Search for Life in the Universe, and Mirror Earth, The Search for Our Planet's Twin. Priyamvada Natarajan. Priyamvada Natarajan, an astrophysicist and professor at Yale, has made seminal contributions to our current understanding of the formation and growth of black holes, the origin of the first black holes, and of the nature of dark matter by mapping it using gravitational lensing. A recipient of many awards and honors, she is also the author of the critically acclaimed Mapping the Heavens, the radical scientific ideas that reveal the cosmos.
What inspired you originally as a child or a young person to be fascinated with the cosmos?
I guess I got started off as a young kid in India being fascinated with maps. And so it really started with wanting to map what seemed untouchable and too far away. So mapping the night sky. And I started with writing a code to make the sky map for Delhi so that you could see, marking out which planets you could see, which bright stars you could see, and so on. But I've always been interested in science. So I was a very curious child, and it was clear that, the kind of hands-on sort of exploration of the natural world with instruments, so I had a telescope and a microscope, so I got started very early.
So especially in your excellent book, which came out a couple of years ago, you talk a lot about the confluence of new technologies and people who found creative ways to use them. And while you go all the way back to ancient times, the Babylonians and so on, we don't have time for the entire history of the world. But since, say, since 1900 or so, can you give us some examples of breakthroughs we've made in understanding the universe and its origin and evolution that fit this mold of better technology leading to new discoveries?
Yeah, so I mean, I make the point in the book that it's really the confluence of sort of ideas and instruments over time that have really propelled radical new discoveries in space science and astrophysics and cosmology in particular. So I think that, you know, when we think about the various epochs in time, human civilization, I think we are at the precipice of a radically exciting, wonderful time in terms of exploration of space in a completely different way, you know, compared to the past, even the recent past. So I know if you look back, so just 100 years, even 100 years ago, we didn't really know. We thought we were the only galaxy in the entire universe. And the astronomer Edwin Hubble kind of disrupted that by showing that Andromeda galaxy was an external galaxy and that the universe was replete with galaxies. Then came the destruction of the notion that we lived in a fixed static universe with the discovery of the expansion of the universe. And then came, you know, as late as 1998, the discovery that the universe was not just expanding, but the expansion was accelerated. And along the while came the understanding and the unraveling of the various components of the universe, many of which are incredibly mysterious. They remain mysterious, like dark matter, dark energy, and black holes. But I think what the future holds is really exciting, because I think that some of these mysteries are going to be cracked open very, very soon.
So that is very exciting, and as you say, we have a good understanding of ordinary matter, but that amounts to only about 4%, I think is the figure, of what the universe consists of. So it's almost as though we and the planets and the stars are an impurity in this universe. So we've learned that there's almost certainly something called dark matter, also something called dark energy, which you just talked about, propelling the expansion of the universe. How do you think we are going to achieve an understanding of these things? Because they're both still entirely mysterious, right?
Yeah, absolutely. I think that, you know, as I alluded to before, we are at a very special time. There's a real grand convergence of computation, the kinds of space instrumentation, and kind of accuracy with which we can make measurements. So for example, the James Webb Space Telescope that is due to be launched very, very shortly will open up to the earliest epochs in the universe. So we will be able to witness the formation of the first stars and the first black holes. And similarly, there are these exciting missions. There are many missions. I'm going to pick ones that I think are most exciting in terms of, you know, my own science. I think one of the big unsolved problems is the real nature of black holes, how they form and how they grow. And the gravitational waves that you get from two black holes crashing, which have been detected for tiny black holes, are yet to be detected for supermassive black holes, which we believe inhabit the centers of almost every galaxy. That stands to be discovered by a mission called LISA, which NASA and ESA are collaborating on, which is going to fly up. It's a configuration of 3 satellites, which will be exchanging light beams, and gravitational waves that are basically earthquakes in space-time will cause disruptions, will cause a little bit of shaking on one of the beams versus the other. Using that, we will be able to infer all kinds of astrophysical information about the 2 supermassive black holes that collided. To me, the kind of technological innovation that measurement encapsulates it's just astounding. It's astounding what we can actually do very, very soon. And I think as for the contents of the universe, as you rightly mentioned, dark matter dominates the matter inventory. We have no clue. We have some idea of what the properties of some putative particle that likely was made in the very early universe, that is dark matter, has. We believe that it's kind of a peculiar lazy particle that travels quite slowly compared to the speed of light. Remember, in the universe, everything, the marker, our benchmark is the speed of light, and it is collisionless. It doesn't have pressure. So, all our normal intuitions about how gases work, etc., everything goes out of the window. But this particle is yet to be found. But I really think it's the next 2 decades when that's going to happen. We really are at a turning point in terms of our understanding, and many sort of new ideas are sort of coming together, and the technology to be able to implement them has also kind of converged. And of course, there's a sort of revolution in thinking about space, right? Sort of other new dimensions that have also just opened up.
And when you talk about a special moment, as I recall, the search for gravitational waves, people have been thinking about that for 50 years or more, and not succeeding until only just recently. So I guess that is really what makes this a special moment. That we
Absolutely.
can finally build the detectors, because these are incredibly difficult to detect, right?
Very, very difficult to detect. Very, very challenging to detect and interpret. These signals are very, very feeble. There are many contaminants, so there has to be extreme care. And especially for the supermassive black holes, at least for these stellar mass black holes, the LIGO collaboration had instrumentation on Earth. And so for detecting these sort of more massive collisions of black holes, you need the same instrumentation actually launched into space, calibrated remotely. So, I think the technological sort of competencies and expertise that is needed to pull this off is just really remarkable. But we have that. Just as as recently as a few months ago now, it is soon going to become routine to be able to just sort of travel into space and come back. So, the human relationship with space, our relationship with space and the universe are really transforming in front of our eyes, right? So we were just sort of passive observers taking data, and now suddenly we are finding that, humans can be launched into space. I think this causes a huge kind of cognitive shift in how we even think about the rest of the universe.
Right, and it's funny that back in the 60s, I remember the first steps on the moon. I stayed up late and watched it on television, so I saw that first step. And at the time, we thought, now we're on the verge of becoming a spacefaring species, and it turned out not to be true at that point. And now suddenly, it's happening. Is it technology that's made this possible?
Yeah, I think that absolutely it is technology and the will, especially. And I think that, while I'm excited, there's also sort of a bit of caution about becoming an interplanetary species. I think that human beings, although we are born innately with a sense of curiosity that has propelled our exploration, first sort of explorations of just our immediate environment, the voyages of exploration around the Earth, and then reaching out to space. I think we need to be really careful about, how we approach the exploration of space. We cannot take our colonizer mentality out to space. It would be very irresponsible, especially because we are demonstrating right now that we're not a very responsible species on Earth. We are succeeding to really destroy this beautiful blue planet, this, sort of lonely rock, the only place at the moment that we know there is intelligent life. we have very successfully brought it to the brink of disaster with unmitigated climate change by our uncontrolled activities. So we've got to learn from this. So I think while it's an exciting moment, it's also a moment of great reckoning and learning for how to approach sort of our own personal human interactions with space. I have to say, I much prefer us in the state that we were, having instrumentation that would go out into space without us going with the idea of mining or extracting something from. I would like the night skies to just be for everyone.
Well, and another problem is the growing numbers of communication satellites, these constellations that are being launched. And I understand that astronomers and astrophysicists are very concerned that view of the night sky you talk about will not be available the way it always has been.
Absolutely. And I think that the fact that this has been a very sort of unplanned, unregulated activity, right? So it's not just SpaceX. There are many, many companies around the world that are planning to put up these communication satellites as we rely all more and more on the internet for our life and connectivity on Earth. And I think that not only does it stand to destroy the night sky for taking data, but we cannot forget that the night sky has been a source of great inspiration for us. And blocking the view to the universe is almost like blinding ourselves to one of the most inspiring cosmic sagas that we're so fortunate to be able to witness. So I think I find that very troublesome. And, and I have to say, there is this tension, right? So there is this excitement at the possibilities that, now we can go and mine an asteroid, and that, there's actually material that this Bennu mission has extracted material that's going to come back to Earth for us to understand. And it'll tell us a lot about the origin of the solar system and other planetary systems and so on. But at the same time, the idea that we are going there to exploit minerals, I find that very uncomfortable, I have to say. And I think there are big ethical questions that we have to address, and we have to address now.
Well, I agree. It sounds like the imperialist expansion from Europe to take raw materials from places that were less developed. It's the same thing all over again. You talked about a couple of things, the James Webb Telescope, and also the idea that there might be life on other planets. We don't know that there's even microbial life elsewhere, let alone intelligent life. But do you have an excitement about our getting a greater understanding of the kinds of planets that are orbiting other stars and the kinds of life that might exist there?
Yeah, I think that has been one of the most exciting developments of the last decade. The discovery of more than 5,000 or so other planets, many of them locked in multiple planetary systems around their parent stars. And I think, yes, this question about the nature and origin of life is super, super exciting. And I think it's very urgent. But I think once again, there we have to caution ourselves that to get ourselves out of our anthropocentric traps, right? So I think it was Stephen Jay Gould, the famous evolutionary biologist, who reminded us that even if we play back the tape of evolution on Earth, you just turn it back and then you run it forward again, we may not end up with human beings like us as the end product, just because of the amount of randomness that is involved in a process where we understand the biological starting points on Earth.
Right.
We may not know where the first organic molecule came from and how it was synthesized on Earth, but we know that if you start out with a set of these biological molecules, we could build life to the complexity that we have today here. But I think we should be aware and remain open-minded that, life might have evolved. And as you rightly mentioned, it could just be microbial life, some kind of primitive life forms, not quite intelligent life forms that might be there elsewhere. On the other hand, given the statistics of the number of planets that we are finding, this is just in our own tiny little galaxy. And given that there are billions of other galaxies, I think, it is not unusual that there likely is, there are other forms of intelligent life elsewhere in the universe. I think we need to remain excited and open to that possibility. I see how not.
Right, right. And what you just said kind of reminds me of a saying that I've heard among physicists and astrophysicists, and it's probably true for other disciplines as well. When we build a new, more powerful telescope, or send a bigger telescope into space, or look at the universe in wavelengths of light that we've never explored before, we discover things that we never would have expected, and so in some ways we raise more questions, or as many questions as we answer.
Absolutely. And for the young people who are watching this, there are plenty of cosmic questions that remain to be answered. So there are lots and lots of, and as Michael just said, every new observation, and now we are making many, many new observations in multiple wavelengths with many new instruments, opens up further sets of questions. So for those of you who are interested in science and are curious, gosh, astrophysics is a gold mine. And I think that there is no question that there'll never be an end to the kinds of things you can know. So for example, even with the James Webb Space Telescope, we know fully well from the specifications of what all it can do and what its windows, when James W opens up its eyes to the early universe, we expect black holes, to see black holes assembling, the first black holes assembling, the first stars likely assembling. So, but we have no idea. These are our expectations, built on what we understand now. But there is always the possibility of finding something completely unanticipated, right? And I think that's what makes it all so exciting.
One example I think of immediately is that when, and it ties in with your fascination with map making, is that in the 1980s, when Margaret Geller and John Huckra from Harvard started mapping the locations of galaxies in the relatively nearby universe, I think, correct me if I'm wrong, everyone expected them to be randomly distributed. And Absolutely. To everyone's astonishment, they were actually organized into great voids surrounded by shells and filaments of stars. Is that the kind of discovery you're talking about?
Wonderfully iconic map that transformed our understanding of even the nearby cosmos at that time, where we had a lot more information, but we hadn't been able to put it together in a three-dimensional way to figure out what things look like. But, I think that there are even more sort of exotic possibilities, right? So we believe we have an understanding of when we believe the first stars formed. So it's quite possible that actually the first stars formed much, much earlier. And so, we've been recently investigating, what is sort of a radical and speculative idea that all of the dark matter might be made up of primordial black holes that were made with a range of masses in the very early universe. And that these black holes then kind of aggregate into kind of halos, which then harbor the regions, they cocoon, and they provide the regions where the first stars formed. If this kind of idea holds any water, then we predict, for example, that there should have been a very, very early first generation of stars, which means JWST may not see any of those individual stars, they would be too faint, but it would detect a faint haze. And so we've actually made a prediction that if that is the case, you would see a faint haze, right? So there are many groups that have explored all these, exciting speculative directions with these sort of observational signatures that might validate these ideas or invalidate them. But I think that, things like finding evidence for the formation of the first stars at a much earlier epoch than we anticipate, or even the assembly of black holes much earlier than we anticipate. I mean, these are the kinds of radical findings. They're radical because they will force us to reorder our map of the universe. Much as you said, Margaret Geller and Huckra's work forced us to re-envision what we thought of the nearby universe and of the clustering of galaxies. So I think, our understanding just stands to be transformed even within a year or two.
Well, I am really looking. May I write about this when this happens? Because this is exactly why I love this field so much as an observer and a journalist, not a scientist. But our understanding of the universe has changed so. When I was very young, we knew about these things called quasars, but nobody knew what they were. They were just completely mysterious. And now we have a very, very good idea.
They are actively growing black holes, that they're quite different from stars, although the term quasars suggested they were quasi-stellar objects because their spectra looked somewhat similar in some ways to stars. You're right. I mean, I think, we have all witnessed multiple revolutions and multiple revisions of our cosmic view, even in our lifetimes right now. And I think that speed is just going to kick up even more in the coming years.
Well, I guess one other thing I wonder about, this is maybe beyond speculative, although some physicists would argue otherwise, the idea that there are multiple universes, that ours is just one of many universes that are disconnected from each other. Is that a crazy idea?
No, I totally believe in this. The operative word, of course, is believe. I think that why not? And I think it makes perfect sense that our universe might just be one rendering. As you know, this suggestion came out of trying to explain the very special conditions that are required to form and evolve our universe, and for us to be here to be able to ask this question, and the fact that there are 6 numbers that are needed to specify the past, present, and future evolution of the universe. And these are measurable, but if these were slightly off, we just wouldn't be here. So, to explain this kind of fine tuning, which seems kind of problematic from an epistemic point of view, it was suggested that there could be multiple universes. I actually love the idea. We are not at a stage where we figured out how to test it. So, our conventional scientific practice of wanting to be able to test and validate the idea, but then, when Copernicus reordered the solar system in 1543, he could never have imagined that human beings would fly out Voyager 1 and Voyager 2 that would leave the solar system, right? And in his view, the end of the universe was the solar system. That was the edge. And so, the course of future science cannot be predicted. But what is awesome now is that we can create this future given the power of technology that we have at our disposal.
And I'm sure you know that some people call this idea about multiple universes, they say it's not even science because we can't test it. And I think that's maybe too narrow a definition of science. What do you think?
Science, the scientific knowledge by nature is provisional. So what we know is only best to date. So at this moment, we have not been able to devise experiments that can test that idea. That does not mean we should discard that idea. I think we should think about how you could test it. So I think there are some speculations that if you had multiple universes, they could bounce and they could collide with each other, and they could generate some kind of signatures that we should likely see in the ancient hiss of the cosmic microwave background in our own universe. They are not yet detected, but I think we need to do a lot more work trying to understand the full panoply of signatures that you could possibly get. I think it's worth investigating these ideas, however speculative they may be, because this is the nice thing about science. The edge of what is fact and what is speculation is constantly moving. We are pushing at it with our efforts, our technologies and instruments and computation.
Well, this is, I get more excited by the moment. Thank you for this wonderful conversation. I really look forward to more.
Yeah, thank you so much. And I think, it is, I can't tell you, I think I've used the word excited like 15 times in every sentence.
Okay.
Yeah, and you can see that it really is a very, very special time to be alive. And I think that for the future, for young people who are thinking about careers in space and space science, hey, there's no time, there's been no better time than to jump right in. Many, many exciting adventures await.
Excellent. Thank you.
Thank you very much.
An innovation can change the world. All we need is passion, focus, and a desire to help. If you have an innovation that spans new thoughts on economics and beyond, please send it to us at whatever stage it is in. Our panel of experts will assess it and help propel it towards reality. The sky is your limit. Don't wait. Mail us your idea or innovative thought at beinspired@teamworkarts.com.